You know that feeling, right? Stepping out of the shade onto like a huge sun-baked parking lot, and the heat just hits you from the ground up.
Oh, yeah. Or even walking through the city late at night, and you can still feel the warmth coming off the pavement.
Exactly. So we kind of get that cities feel different temperature-wise,
Mm.
but what's really going on right there on the surface?
It's a mechanism, yeah, how heat actually interacts with all the stuff in our cities.
And that's what we're digging into today. Surface urban heat islands, SUHIs. We've got this really fascinating research paper looking at Tabriz in Iran. They used 20 years of NASA satellite data, 2003, right up to 2022.
20 years, wow.
Yeah, it tells a compelling story about how this city heats up, cools down, and they even forecast what might happen next.
That forecasting part sounds pretty intriguing. These SUHIs, they matter a lot, actually.
So let's break it down. What exactly is a surface urban heat island?
Well, broadly, an urban heat island, or UHI, is just an urban area that's warmer than its surroundings. But a surface urban heat island, the SUHI, is specifically about the temperature of the actual ground, the buildings, the roads.
Stuff you can measure from space.
Exactly.
Right.
Satellites measure that land surface temperature, or LST. It's different from the air temperature UHI people might be more familiar with.
Gotcha. So, okay, surface temperatures. Why is this such a big deal? It sounds maybe a bit academic.
Oh, it's far from just academic. It has huge real-world consequences. Think about public health. Extreme heat hits vulnerable people hardest, and SUIs make that worse.
Right.
Plus, energy demand, everyone running their air conditioning.
Yeah.
And it can even make things like smog worse.
Yeah.
So yeah, understanding SUIs is really critical for city life.
That makes sense. Okay, so how did the researchers actually study this in Tabriz? Over 20 years, that sounds complex.
They used data from NASA's MODIS instrument on satellites. That gave them that consistent LST data record. They had to carefully define the urban boundaries of Tabriz and then select reference points in the rural areas nearby, specifically bare soil areas, to get a good comparison.
Comparing city surfaces to bare ground outside.
Right. And the SUHI intensity is basically the urban temperature minus the rural temperature. Simple idea, but powerful. They also use some pretty advanced methods to analyze trends over time, including one called innovative trend analysis, which is apparently quite new for SUHI studies.
And Tabriz itself.
Yeah.
It's a big city. What's the environment like?
Yeah, about 2 million people. It's in northwestern Iran in a cold, semi-arid region. So think dry, hot summers, but cold, snowy winters. And importantly, it's surrounded by a lot of barren land, but also some irrigated farmland, particularly to the west.
Okay, so unique setting. What did they find? You mentioned surprises. Let's talk about daytime, say at around 1:30 in the afternoon.
Okay, get this. This is the really surprising part. During the day, Tabriz often acts as a surface cool island.
Wait, a cool island? Colder than the surrounding area?
Yeah, significantly colder sometimes, especially in summer. The average difference was almost -4 degrees Celsius, and in one summer, 2018, it peaked at nearly -9 degrees cooler than the rural land.
How is that even possible for a city? We always think cities go hot.
It's all relative. Those vast, barren lands surrounding Tabriz, they get incredibly hot under the sun because there's no vegetation, no moisture for evaporative cooling.
Oh.
But the city itself and those irrigated areas nearby do have vegetation, trees, maybe some water bodies. That provides evaporative cooling, making the surface cooler compared to that superheated bare ground. We see this in other cities in arid or semi-arid regions too, like Phoenix.
Fascinating. And what's the trend for this daytime coolness? Is it changing?
It seems to be generally strengthening, actually. The analysis showed a significant decreasing trend for the SUHI value, meaning the city's getting relatively cooler during the day, especially in summer.
Wow. Okay, so daytime is unexpectedly cool. What about night? Around 10:30 p.m., is it a complete flip?
Completely. It's a total flip. At night, Tabriz becomes a very intense heat island, significantly warmer than the surrounding countryside.
How much warmer?
The annual average is over 3 degrees Celsius warmer, but in autumn, it averaged almost 5 degrees warmer, and they saw peaks close to 10 degrees Celsius warmer back in 2016.
10 degrees. That's a massive difference. Why such a huge swing from day to night?
It's that thermal battery effect we often talk about. All the concrete, the asphalt, the building materials, they soak up solar energy all day long.
Right, storing it up.
Exactly. And then they release that stored heat slowly throughout the night. Meanwhile, that bare soil outside the city, it has low heat capacity, so it cools down really quickly once the sun sets. That creates this really stark contrast.
Makes sense. So given how intense it is the nighttime heat island getting even worse over time?
Well, here's another nuance. Despite the intensity, the trend analysis actually showed it's been slightly weakening overall. The SUHI intensity at night has a slight decreasing trend in most seasons. Autumn was the exception, showing almost no change.
So the cool island is getting stronger, and the heat island is getting slightly weaker. That's complex. What do the forecasts say looking out to 2030?
Using the better performing model, they predict a slight uptrend for the daytime SUHI, meaning that cool island effect might weaken a little bit by 2030.
Okay, less cool during the day.
And for the nighttime, they predict a continued downtrend, suggesting the heat island effect will weaken more considerably by 2030. The city might be only slightly warmer than its surroundings at night, on average.
That paints a very nuanced picture indeed. So what does all this mean for, like, urban planning? Especially in these dry cities where water's an issue. Generic solutions probably won't cut it, right?
Absolutely not. This research highlights how crucial it is to tailor strategies. You can't just apply a one-size-fits-all approach copied from, say, a temperate city. You need to consider these specific day-night patterns and the local climate.
So what kind of tailored strategies does this point towards?
Well, smart greening is key. Using native drought-resistant trees is important, obviously. But think about deciduous trees. They provide shade in the hot summer, helping that daytime cooling.
Right.
But then they lose their leaves in winter, letting the sunlight through to warm things up a bit when it's cold, which could reduce heating needs. Also, things like urban parks acting as cool refuges.
Makes sense. What else?
Protecting those irrigated agricultural lands around the city is really important too. They provide a big cooling service. And then material choices within the city using roofing and pavement materials that reflect more sunlight, what we call high-albedo.
The lighter colors.
Often, yeah. And materials that release heat quickly at night, high emissivity, and where you have to use dark, heat-absorbing materials, maybe think about artificial shading structures.
Okay, so it's really a package deal. Smart trees, protecting nearby farmland, choosing the right materials, maybe adding shade structures, all tailored to that specific climate and those weird day-night flips.
Exactly, tailored to the local reality.
So wrapping this up, we've gone from just defining heat islands to seeing this really complex thermal dance happening in Tabriz. Daytime cool islands, really intense nighttime heat islands, and forecasts suggesting more shifts are coming. It's amazing what this kind of detailed analysis reveals.
It really drives home how valuable that long-term, detailed satellite data is, doesn't it? You move beyond just saying cities are hot to actually understanding the how, the when, and the why for specific place.
And for you listening, this deep dive into Tabriz, it's really more than just one city's story. It's kind of a window into the complex thermal challenges a lot of cities, especially in these drier parts of the world, are dealing with right now, and will probably face even more in the future.
Yeah, understanding this local nuance, this granularity is just absolutely essential if we want to build cities that are resilient, that can actually cope.
It definitely leaves us with something to think about, doesn't it? If we really understood these subtle shifts day-night, season to season, how could that change how we design everything? Not just the big stuff like roads and buildings, but, our local parks, our building codes, maybe even our daily routines, like when we open windows or use public spaces. How can we use this kind of knowledge to make our cities genuinely more comfortable, more livable, especially as the climate keeps changing?
That's the critical question, isn't it? How do we adapt intelligently using the best information we have?